So hello everyone. Yeah, everyone can hear me. Right, so my name is Chiang and I'm from By Implication. What I'll be talking about right now is something related to game development. Usually when you're making a game, you have different aspects of your game. You have the actual code that makes up your engine, all of your libraries and stuff. You have the actual art and graphic stuff. You've got your music and audio, more assets, and of course things which are not really assets, but are still part of the game, like your levels, your characters, basically your parameters. And one of the problems that I think comes up if you're a small indie team that's starting up like us is how do you manage to integrate all of these? Because obviously a programmer is not good at art, and an artist is not usually good at programming. Of course you have exceptions, but these different kinds of people live in different kinds of worlds. They don't really understand the constraints that one imposes on one another. So what I'm going to be talking about is our experience in developing tools, that sort of form the glue or the bridge, if you will, between these different kinds of assets. So this talk will actually be a little bit technical because I'll be, talking about, the development and production process, but I hope it will be useful to some of you, or hopefully all of you, or yeah. Click. So a little bit about us. So who am I and why should you be listening to me? So I'm from By Implication. Normally, this is the slide where people have some very nice big numbers, like we've made double-digit, triple-digit amount of games with so-and-so amount of revenue. But no, we're just a small team, about 9 people. We were founded just over a year ago, fresh out of school. And I'll just go here and click. And what we've been doing so far is what we'd like to do is create our own projects like games and the like. But in order to get there, we've also been doing a little bit of consulting and outsourcing. And what we do kind of spans the entire spectrum. So we're doing mobile stuff, we're doing on iOS, Android, we're doing desktop stuff, Mac PC, HTML5 web stuff, not so much Flash, and a lot of other weird things, including things that are not even related to games. But of course, since this is we're at Casual Connect and it's about games, I'll be talking about a couple of our games and our experience creating these workflow tools. But out of these 4, 2 of them are actually examples of when we didn't need these tools, and the other 2 are when it actually became a little more necessary. So the first game that I'm going to be talking about is also the first game that we did, and which sort of put us on the map. I don't need audio. Okay, right. That's just there so you know what it looks like while I'm talking about the actual game. So this game is called Wildfire, and it was an entry to Microsoft's Imagine Cup, which is this sort of competition thing. There were about 4 of us that worked on this game, and the theme was about the Millennium Development Goals, so stuff like poverty, environment, and other social issues. And the game is basically about how you can use volunteerism to address these big problems. And it was inspired by a personal experience that we had in the Philippines, where a typhoon struck Manila, and it just inspired a lot of people to work together. So that's sort of how it works. You talk to people, you make them aware of the problems, and then you bring them to different places in the city. So while it's very nice, and we were very proud of it, there's actually not a lot of problems when we're talking about assets here. Because if you look at the buildings, they're all white. Yay, no textures. If you look at the people, sure, there are a lot of people, and it looks very active and very engaged. But all these people, the dynamism comes from the fact that there are a lot of them, and they're engaging in swarm behavior. If you look at each of the individual people, they're just boxes. They're very low poly models. So there wasn't actually a lot of difficulty in producing the assets for this particular game. A lot of the positions, dimensions, zones, and the parameters are also largely hard-coded. So for example, you saw that menu thing earlier. The positions for those in the sprite sheets were also largely hard-coded. So there was no problem in terms of that too. And then when it came to actually bringing the assets into the game, a lot of it was already readily supported by XNA. We just used the content pipeline, which supports OBJ and FBX format. We just slapped it in there, and oh, it works great. So there was no problem in terms of that. When we created, and this is just a big overview. So again, no problem. The other thing that we had was procedural generation, which basically means that instead of us creating levels, we basically made a bunch of rules that went, okay, let's start out with a block. Let's chop that up into major sections, which we call highways. And then we have smaller sections, which are streets, and then even more sections which are sort of like alleys. And at the end, you just sort of pull that out at different heights. You get buildings. And then the resulting lines, that's your road network graph. So it was very simple. Well, the math and the programming was not simple, but as far as art and assets were concerned, it was pretty simple. So with this sort of look, there was really no problem at all. And if you're familiar with the indie developer meme, too lazy to design levels, use procedural generation, which you'll actually find is a common theme in a lot of indie games. So yeah, next game I want to talk about is this thing called Escalation. It's a really, really simple game, a lot, really pixel art sort of thing. And it had a very flat structure. So it was really, really a bunch of sprites. And then, since the game was actually about this kid over there, and then there's an escalator going down. And then what you do as a naughty kid would do would be to run up the escalator. And the way that you'd play the game is by doing a motion like this, and then swiping left and right to avoid obstacles. So again, the actual level is just, spawn a bunch of obstacles left and right randomly, maybe in the middle. And your assets are pretty much straightforward. Just put a bunch of sprites here, and ta-da. So there was it was all good. We had to manually manage a lot of things, and it was largely hard-coded, but there was really no problems that we encountered here. I'd be walking a little more than I thought. So those are the two games which, we didn't have much problems on. Now, our next game, which is actually the first that we have of our own that's on the App Store now, so you can actually go get it if you like, is called Scram. And it's sort of this atmospheric first-person running game that's made for the iPhone and iPad. And it was actually, again, we're still doing a lot of outsourcing consultancy work. So we actually did this in parallel with the rest of that work. So that you have a better idea of what it is, I can actually just play the trailer. But it's a little dark, so oh well. Okay, you can't really see it that well here. But basically, what happens is that you're running through corridors, and then there are these lights up top, and then they're sort of constantly shut off. And then the idea is that you're running after something, and as you hit obstacles, you stumble, you lose a little bit of, you lose traction, and then you sort of slow down. The lights get farther and farther away, and you fall farther and farther into the darkness, and something just pulls you, but you can't really see it here. So yeah, so that's Scram, and it's on the App Store. But anyway, so it's actually still a very simple game, still relatively random and relatively procedural, but there are certain differences that, from Scram and the other games that we had earlier. First was that it was a shift to a data-driven architecture, and what that basically means is there was no more hard coding. For the level of complexity that we really imagined it to be, hard coding was simply not reasonable. Like, we couldn't say we'd have a tunnel 400 meters long and then we'd individually put each of the elements in the tunnel. That's a little crazy, not to mention very repetitive and predictable if you play the game again. So you had to separate the level data from the program logic. This is probably obvious to a lot of you. The other thing is that it's not a flat structure anymore, whereas before you only really had one kind of asset. You only had a flat 2D sprite thing or 3D models without textures. Now we have models that have textures which are related to one another. Sometimes only these models can go with these models because it's related to the level and all of this. And when you can manually manage that, it really doesn't make sense, and it's not scalable once you have a bunch more levels and obstacles. So alas, you can't do this. Now what? Besides the whole procedural thing, there's also the difference that fundamentally the two games, while this looks a lot fancier and that looks a lot simpler, they're actually both simpler in terms of the implementation. So while it was a 3D environment in Wildfire, it was still actually 2D gameplay, and the maps are completely procedural. In Escalation, everything was 2D. In fact, you could argue the gameplay was kind of 1D because you're just running up an escalator. And the objects are all random. For Scram, it was first person, so there had to be a lot more detail. The frame rate had to be a lot higher. The immersion had to be better because we were going for an immersive game. The gameplay was first person as opposed to it being 2D flat actual on a plane. And the levels had to be kind of random, kind of procedural, but at the same time not totally random, because what if the random generator kept rolling a 6 and then you'd all have obstacles on the right? That would be silly. So you had to give something that had a degree of randomness while still being rigid and predictable, which I'll talk about in a little bit. So the first problem, there are several problems. The first problem is actually the art. When it came to Wildfire, since we're running it on a nice computer with nice tools and everything, we could just shove in our existing models and XNA would automatically just accept them. On iOS though, the ideal format to be doing to be using models with is called the pod format, which is a proprietary format that PowerVR Imagination technology does. So all of the smartphones actually use PowerVR chips, so all of them have to use pod. The thing I also should mention here is that most of the tools that people expect, like Unity, like Ogre, and all of these other engines, probably already do this for you. But since we're small and don't want to pay anything for any engines, and because we're kind of ambitious and want to do everything ourselves the hard way, we wrote our engine from scratch using OpenGL and writing our own parsers for all of these things. So that kind of explains why we're doing this whole conversion thing. So the models from our modeling program, we had to convert them first to Koyada, which is the sort of open interchange format, and then convert that to pod. Same with the textures, there's an optimized format. While you can use PNGs in normal games, it's not ideal if you use it in 3D games because the format is not optimized for use as textures. And then, of course, there's the problem that the models, of course, refer to textures. So inside the model, there will be paths to textures, and you'd have to rename those or refer to the updated ones, which are converted. So your workflow at the bottom, sort of looks like this. And of course, there are a couple of problems here. There are too many steps, period. It's easy to forget the commands. Koyada to pod is what you use to convert the models, and text tool is what you use to convert the textures. And if you're an artist with no background in programming or what have you, you'll probably like, what the hell am I doing? This doesn't make any sense. I'm making incantations which I hope work. And of course, it's tedious. That is to say, the process has to be done for every asset, for every obstacle. And of course, you don't want to be limited to 1 or 2 obstacles after getting tired of converting. So it has to be made simpler. And besides that, we also have level descriptor files, which state what assets are in a level, what assets go to which obstacles, which go to which levels, and parameters for the level in general, like how bright it is, what music there are. And here comes the thing I was talking about earlier. Because we're weird and crazy, we ended up creating our own mini programming language, which is declarative, which dictates how obstacles are generated in the level. And if you're wondering what that looks like, it looks like something like this, which I'll actually discuss in a bit, so don't worry. The obvious solution is, since we're already defining what all of the parameters are, like what obstacles there are, what their models are, why not just make a tool that, in addition to processing the level, right, so the game knows what levels in what, why not also process all of the assets? So in the process of preparing the level, you also prepare the assets. So we came up with this. So basically, that's the name of our script, and then the thing on the right is the name of the level. So it's basically and again, since we don't want to pay anything for any fancy tools or engines, it's basically a Perl script which processes the level file and calls a ZSH script, which is basically one of the terminals in Unix and Mac OS X, which then calls make, which if you're a developer is what you use to actually start a GCC compiler. And then, it's actually a very convoluted process, and we use make for caching because it's what, when you compile stuff, you do it often. If you have binary code that's already there, you don't want to compile that again. And because we didn't want to write our own caching thing, we used make. So a little roundabout. And while it seems like, okay, it solves our problems, it's not like it didn't create problems of its own. While the goal was to create a tool that was simpler to use than the existing built-in tools that are provided by the SDK, since we built it ourselves, we didn't think, okay, we'll just use it properly and hopefully there'll be no errors because we're using it properly. But of course, you make mistakes, you forget things, and so the artist will blame most of the problems on the tool, even though if it's the artist's fault because they're not sure what they're doing. Our workflow also is that we use Dropbox for the assets. We use Git for code, of course, but you can't really use Git with assets, especially if they're big. So we use Dropbox, and Make does not casual with Dropbox, so that's another problem. The third problem is what I like to call path hell. And if you know what a path is, it's basically a line that tells you where a particular file is. So if it's in like /folder/file.jpg, file.jpg is in folder. But the thing is, for whatever reason, big commercial modeling programs like like Maya, Autodesk Maya, or Luxology Modo, weirdly enough, make weird paths. Even if you have your model here, and then your textures are in one folder, the path that they'll spit out is something like that, which basically means something like, okay, you have this thing in this folder. The file is here, but it's in the folder that's above in A, it's in the folder that's above in A, in the folder that's above in this folder, and then it's T, instead of just saying /A/T. And while you can, that's not something that we can control because it's a proprietary program and it spits that out, and you just have to deal with that. But it causes problems when you're reorganizing files. And where is this file? And then you, as a human, have to parse this weird-looking string. Okay, I think it's there. Or you end up editing it manually, which doesn't make sense either because that eliminates the benefits of automation. And finally, our tools didn't have error checking. And while again, the expectation was, okay, if you use it properly, there are no errors. But if you're not careful, then errors will occur. And because it doesn't check for them, you'll cause weird bugs in the program. And we'll be like, well, our programmer, there's something wrong with this. If I do this kind of thing, then the game crashes or something doesn't appear. And he'd spend like a couple of hours trying to debug it. And he'd get really frustrated because he doesn't know where the problem is. And it turns out it was in our level specification because it didn't catch the error. He spent a lot of time looking for what was more or less a non-existent bug. So I'll just simplify what this is. Mid-development, we wanted to create, we want to enhance the game itself. We wanted to add more to make the obstacles more dynamic, to make them move. So this was actually an opportunity to improve the build tool. And I'll describe actually the format here. Basically, it's sort of like an ini file. And what we have here actually is basically, where's my mouse? Yeah, there you go, that's great. Basically, what's the environment texture, what's the brightness base, what's the range of the brightness, what's the darkest to the brightest, how long is it, how, what are the length of intersections, what's the spacing, blah, blah, blah. The next thing you'll notice is, okay, you can have textures for models, you can specify those here, but how do we create that sort of thing where I said, obstacles have to be sort of random, but not entirely, there has to be some structure. What we do actually is that for obstacles, why won't it go to the previous slide? For obstacles, we actually, in addition to saying what's the path to the model, we also say, okay, this is basically, you can only move through it, you can only get through it by going to the top or by jumping. This one you can jump or you can go to the left or right. This one you can only slide underneath. So we specify those. And then we all categorize them into class A, class B, class C. And then up here, we have something called patterns. And then basically this means get an obstacle from A. This one means something like C, then any obstacle, then one from class C, then one from class C. Then this is actually an animation sequence. So basically, these are the frames. Again, because we wanted to keep it simple, we didn't actually want to put a real animation support. So we created intermediary frames, each as models. And then these are the parameters. So do they cycle? Is it random? How long? And stuff like that. So yeah, we may have over-engineered this a bit. And finally, we added error checking to the thing. So not only does it process the thing, it actually says, okay, I'm ignoring this. Okay, you're stupid. Okay, this is really stupid, and that sort of thing. And in addition to that, we actually also had to create our own documentation for the own stuff that we make, lest that we forget what they do and what we're doing. So again, this is each of the commands and parameters for each of these. So for example, what are the metadata like? Oops. Okay, whoops, there. What are the metadata like? So for example, if you wanted to say left, it corresponds to these, blah, 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 and then a bunch of examples. So our lovely programmer had to, besides panicking about over how to create these tools and how to properly accept them in the game, he also had to create, the documentation for us. Finally, there's this other game that I wanted to talk about called Farobo. It's really cute. Again, another pixel art-based thing going away. So it seems that we do 3D, 2D, 3D, 2D for whatever strange reason. It's a game that was actually made for the Global Game Jam. So it was done in like less than 40 hours. It says 48, but it's actually less than that. So it was something hastily put together, so there was not a lot of sanity in architecting the thing. And the idea that we have is that it would be frustratingly cooperative multiplayer action. And what does that mean? There's a single robot that's made up of 4 individual robots, but each of them do one single thing. Like one of them can only go forward and backward. One of them can only turn the robot around, and then one shoots and one fires. So the way that you'd have to go around the level is you'd have to coordinate, okay, turn a little bit to the left, go straight, shoot that thing, no, that other thing. No, what are you doing? You're getting hit. Okay, shield us. Oh, wait, you shield dead and shot at the same time. Now we shot ourselves. Ouch. And then, of course, whenever you incur damage like that, your positions swap around. Which of course creates more frustration. So it's like a negative feedback loop encouraging you to like cooperate with one another, but I don't know, very harshly punishing you when you mess up. So perhaps not the most friendly thing, but hey, we only had less than 40 hours. So one of the problems here is that, and so you can sort of see what I mean here. So this guy goes, one guy controls back and forth, the other guy controls turning around. And then the other 2 are just shooting and shielding, so I didn't include it here. Of course, so we started out, okay, maybe you don't want to do procedural, you want to make real levels. And since I was in charge of that, I thought maybe we could use a spreadsheet of some sort, and I thought, no, this is terrible, what am I doing? I'm basically drawing in Excel. This is crazy. But thankfully, this didn't push through. Because if you think about it, if you're doing what is effectively drawing, then why not just draw? So what we did was that we made the level file basically a bitmap. And then by drawing, a particular color refers to a particular tile. So if you have this color, that means it's the first one, it's referring to this one here. And then these 4 refer to 3, 4, 5, 6. I'm simplifying because it obviously doesn't look that way, but it's something like that. So you use the different colored pixels as tiles, and then we had sort of a lookup table which specifies which tiles went to which pixels went to which tiles. Okay, since I have about a minute left, I'll speed things up. So some takeaways are that constraints are perceived as a bad thing, because, oh, I don't get to do anything, I have to do this. But they're usually good. So in terms of competitions, it gives you a theme and the like, blah, blah, blah. But in terms of the process, if the developer says, no, you can't do this, you have to do this, it helps you, specify what kind of art style you should take, what kind of, models you should take, and the parameters like that. And everything relies on each other. That's another problem. The gameplay will depend on what the story is like. If you want to be a narrative, will also depend on what the graphical effects are like, because you can't use this. Will also affect the overall direction and how you can expand the game. Because if you do everything in a particular way, then there's no way to bolt anything onto that. So you have to decide on what's most important and adjust the other elements as necessary. Besides the constraints on the thing, there are also people constraints. So you might make the most awesome and most hackable tool ever, but if your designer doesn't know how to use it, it's useless. So there's that challenge between making something that's flexible and hackable and being user-friendly. Finally, as was discussed in numerous other lectures, iteration and playtesting is always important, so your tools also have to be oriented toward this. It should be quick and easy to adjust something. You shouldn't have to compile the whole thing. you should make it such that you can actually put your level somewhere that's separate from the thing. Maybe you don't even have to rerun the game. Don't require a new build and compile. And if you're really ambitious, try to have live editing. And finally, other potential advice that I didn't discuss earlier, make sure if you're doing a lot of effort to make your own things, at least try to make them reusable. Boom's app, I think, does a lot of this, so they get to reuse a lot of their engine for each game. And if they improve anything on a particular game, they get to use those improvements moving forward. Since all our games have been very different, and because we're weird and like to do things the hard way, we've built a lot of engines that only get to be used in each of those games. So don't do that, unless you're really, really ambitious and think it's worth it. An alternative, of course, is to go off the shelf. Use something like Unity or Ogre or one of the many other engines. And this will help you get up to speed really quickly, but at the cost of flexibility. If there are existing tools, adapt to them. So if there's something that's better at packing textures, use that. And if your external tools are crappy, like Autodesk or Maya or Mixology Modo or what have you, avoid them because they only give you headaches when you try to adjust to them. And of course, always assess whether something is worthwhile. And finally, the most important thing is a non-technical thing. Make sure you communicate well as a team. In large projects, it might be difficult, which is why I have project managers and whatnot. But speaking as an indie developer, it's the one thing that you probably have over these large groups. You can literally go over to the developer and designer or artist and say, "What the hell are you doing? This is wrong, blah, blah, blah." So there's very immediate feedback. Sometimes it's a slap to the head. And there's no real replacement to that. So thanks for listening. I hope that was useful. You can follow, like us, or go to our website here. Or you can follow me on Twitter here. That's my handle. So are there any questions? No? Yes. Yeah, they're both. Yeah, go ahead.
You said the topic was developing on an indie budget.
Yeah.
What's a ballpark figure for it?
Indie budget. Well, we did this by ourselves and didn't pay anyone to do it. So you could effectively say zero. The thing is, though, of course, nothing is ever free. You paid for something in time, which is why I talked about, is it worthwhile building this thing? What will this let me do that I couldn't do by getting Unity and paying for the license for that? So that's sort of the thing that I kind of wanted to say also. Did you have a question? Yes.
How do you see the future? How do you keep the sustainable your company or your team?
All right. Yeah. This doesn't sound very sustainable, I know. But the goal is that once you have more revenues, once you have more, once we're able to build that, then besides, of course, being able to, pay for the larger packages, although they're actually more competitive and accessible now, our team will also grow. We'll develop more established workflows. We'll develop more established tools. So yes, anything else? All right, I'm actually a little bit over time, so thank you very much, everyone, for listening. I hope it was helpful.